So in this video, we're going to look at scenarios where we have to combine counting methods. So we may have to combine, say, a couple of permutations together, or we may have to combine combinations together in order to be able to determine the number of ways that something can occur. So we'll take a look at this through a couple of different examples. So example 9. A committee consists of 7 men and 9 women. If 2 men and 2 women will be selected to attend a conference in Washington, D.C., how many ways can the conference attendees be chosen? So this scenario is a little different from other scenarios that we've done because we have a committee and we're breaking that down into men and women. So there's 7 men, there's 9 women. Now we're going to pick 2 men out of the 7 men, obviously, to go to Washington, D.C., and we're going to pick 2 women out of the 9 women to go to Washington, D.C., and so we want to know how many different ways can the conference attendees be chosen. Well, if we're just picking 2 men out of 7 men, so the number of ways we can choose the men is going to be that we're going to have a combination of 7, and we're choosing 2. So again, it doesn't really matter the order that the 2 men are picked, so that's what makes it a combination. So again, we have 7 men, we're choosing 2 of them, and again, we could use our other notation if we wanted to. Now, I'm going to just use my calculator to calculate that. So if I do 7 probability combination, choose 2, that's 21. There are 21 different ways that we could select the 2 men out of the 7 men. Now what about the women? Well, there's 9 women, we're selecting 2 of them. So that would be a combination of 9, choose 2. Or again, we could use our other notation. So again, it's a combination because the order that the 2 women are selected doesn't matter. So if I pull back in my calculator, 9, math, probability, combination, choose 2. So there's 36 different ways that we could choose the 2 women. So there's 21 ways we could choose the men. There's 36 ways we could choose the women. Now, each one of these 21 could be matched with each one of these 36. So altogether, there would be 21 times 36 different ways that the conference attendees could be chosen. So again, there's these 21 ways the men could be selected. There's these 36 ways that the women could be selected. So there will be 21 times 36 different ways of selecting the conference attendees. So if I do 21 times 36, that is 756. So there is a total of 756 different ways that the conference attendees could be chosen. Let's take a look at example 10. Very similar kind of problem. A ticket for the multi-state lottery Powerball is obtained by selecting 5 regular numbers from 1 through 69 and 1 Powerball number from 1 through 26. How many different Powerball tickets are possible? So this is the way Powerball works. You pick 5 regular numbers, so the regular numbers are 1 through 69, and you pick 5 of them. And then you pick 1 Powerball number, and those have to be something from 1 to 26. So how many different Powerball tickets are possible? Well, so to figure this out, we're going to figure out how many ways could you choose 5 regular numbers, and then how many ways could you choose the Powerball number, and then we're going to put those together. So let's talk about the regular numbers first. Now again, with choosing lottery numbers such as Powerball, the order that the numbers are selected doesn't matter, so that makes this a combination problem. So we're going to have a combination for the regular numbers of 69, choose 5. Again, we could use our other notation, combination 69, choose 5. So if I choose my calculator to calculate this, I do 69, math, probability, combination, choose 5. So that can happen in 11,238,513 different ways. So there are 11,238,513 different ways that we could select the 5 regular numbers in Powerball. Now what about the Powerball number? Well, we're going to pick one number out of 26. So that would be a combination of 26. Choose one. Again, we could use our other notation. Now I'm going to show you this on the calculator, but if I do 26 math probability combination choose one, that is 26. So hopefully that makes sense. You're picking one number out of 26, so there's 26 ways that could happen. So how many Powerball tickets are possible? Well, if we take the 11,238,513 different ways of choosing the regular numbers and then multiply that by the number of Powerball numbers, that will give us the total number of Powerball tickets possible. So we're going to take the 11,238,513 and we're going to multiply that by 26. So if we do that, 11,238,513 times 26, so that gives us 292,201,338. So 292, 201, 338. So there are 292,201,338 different Powerball tickets that are possible. Example 11. An Uber driver picks up Annie and Ben at point P shown on the map. If the driver is to drop off Annie at point A and then take Ben to point B, how many different direct routes can the driver take? So if we take a look at this map here, Annie and Ben are here. The Uber driver picks them up. And so the driver has to drop Annie off here at this point and then drive Ben on to this point. So the idea is the driver is going to go directly, right? So the driver's not going to like go here and then go back and so on. So he's going to go directly. So for example, the driver could go like down here and then over to Annie and then down here over to Ben. That would be one possibility. Or the driver could go down here, over, down, over, down, over, down, and then over, and so on. So there's a lot of different possibilities. But the driver's not going to go over here and then go back to Annie. He's going to go direct. So how are we going to figure this out? Well, first of all, we need to figure out how many different ways can the driver get to Annie's house. And then once we get to Annie's house, how many ways can the driver get from Annie's house to Ben's house? Well, how am I going to figure that out? How many different ways can the driver get from this point to point A? Well, we have choices on how the driver is going to go, say, block by block. So the driver could go right, down, or right, down, or down, right, or so on. So the point is, he's got to go over to and down to. So he's got to go right to and down to. So getting from point P to point A, there's a total of 4 blocks that have to be traveled. And of those 4 blocks, 2 of them have to be right and 2 of them have to be down. So we can get the number of routes from P to A by thinking of that as a combination. That is a combination of 4 blocks, and we're going to do 2 rights and 2 downs. Now, in the same way, to get from point A to point B, there's a total of 6 blocks. So it's going to be a combination of 6 blocks, and of those 6 blocks, 4 of them have to be to the right, 2 have to be down. So I can either do a combination of 6 choosing 4, or if you prefer, I could do a combination of 6 choosing 2. Those would actually be the same thing. Now again, if you prefer, we can use the other notation. So I need to figure out the number of combinations of 4 items selecting 2 at a time, and I need to figure out the number of combinations of 6 choosing 4 at a time. So again, I'm going to use my calculator to do that work. So 4, math, probability, combination, choose 2. So that is 6. And then 6, math, probability, combination, choose 4. That is 15. So this is 6, this is 15. So there's 6 different ways that the driver could get from point P to point A. And then from there, there's 15 different ways that the driver could get from point A to point B. So altogether, there will be 6 times 15 different ways that the driver could go from P to B, but going through A. So if we take 6 times 15, that is 80. There are 80 different ways that the driver could go from point P, drop off Annie at point A, and then deliver Ben to point B. A total of 80 different paths. Now to conclude this video in this section, I just want you to remember Pascal's triangle. Pascal's triangle, if you will remember, consists of rows of 1s and other such numbers. So we start with row 0. Row 0 just consists of 1, and then row 1 consists of 1 and 1, and then row 2 consists of 1, 2, 1. And if you'll remember the way this works, the 2 comes from 1 plus 1. Row 3 starts with a 1, and then 3, that 3 comes from 1 plus 2 gives us 3. 2 plus 1 gives us 3, and then ends in 1. Row 4 starts with a 1, 1 plus 3 gives us 4, 3 plus 3 gives us 6, 3 plus 1 gives us 4, and then ends in 1. 1 plus 4 gives us 5, 4 plus 6 gives us 10, 6 plus 4 gives us 10, 4 plus 1 gives us 5, and then ends in 1, and so on. So again, row 6, 1 plus 5 gives us 6, 5 plus 10 gives us 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, ends in 1. So if we wanted to find the next row would start with 1. This is row 7. 1 plus 6 would be 7. 6 plus 15 would be 21. 15 plus 20 would be 35. 20 plus 15 would be 35. 15 plus 6 is 21. 6 plus 1 is 7, and it would end in 1. So we just keep going like this. If you'll remember, we discussed this a while back when we talked about sets. The reason why I'm mentioning it now is because Pascal's triangle is related to combinations. And so here we have combinations from Pascal's triangle. The rth entry of the nth row of Pascal's triangle is the combination of n choose r. So first of all, the first entry is considered entry 0. This is entry 1, entry 2, 3, 4, 5, 6, 7, and so on. So for example, if we take a look at that number right there, that would be the 1, 2, 3. That would be the third entry of the 7th row. And so that comes from the combination of 7 choose 3. So that 35 is the combination of 7 choose 3. Just to prove that, if I do 7 math, probability, combination, choose 3, that does give me 35. And in the same way, this would be the combination of 7 choose 4, combination of 7 choose 5, combination of 7 choose 6, combination of 7 choose 7. This would be the combination of 7 choose 0, 7 choose 1, 7 choose 2. So there's a relationship between Pascal's triangle and combinations, and I just wanted to point that out. That concludes this section. You should now be able to handle the Section 12.3 homework and the Chapter 12 quiz.